Hello, and welcome to Team 4's presentation of Chapter 11. In Objective 1, we'll use the terms even, odd, factor, multiple, prime, and composite correctly, and recognize statements using these terms as true or false with reasons for your decisions. A definition of each of these terms can be found here. Even numbers are numbers divisible by 2. Odd numbers are integers not divisible by 2. Dividing by 2 would create a fraction. Factors are a number or quantity that when multiplied with another produces a given number or expression. Multiples are numbers that can be divided by another number without a remainder. A prime number is a natural number greater than 1 that has no positive divisors other than 1 and itself. A composite number is a positive integer that has at least one positive divisor other than 1 or the number itself. In Objective 2, we learned that a composite number has more than 2 divisors and a prime number has a divisor other than 1. The number 1 has neither of these qualities. Therefore, it can't be considered prime or composite. In Objective 3, we use the sieve method. Here we show exactly how to go about doing this. We know that if the given number n is 10, then the prime numbers are 2, 3, 5, and 7. In Objective 4, we learned that the fundamental theorem of arithmetic states that every positive integer except the number 1 can be represented exactly in one way apart from rearrangements as a product of one or more primes. In Objective 5, we use the unique factorization theorem. In Objective 6, we're told to use the divisibility test to tell whether a number is a factor or divisor of a given number, but without having to divide the given number by the possible factor. A divisibility test for 2 states that a number is divisible by 2 if and only if 2 is a factor of the ones digit, i.e. the final digit. 9076 shows the last digit, or the digit in the ones place, is 6. That number is divisible by 2. Therefore, that's the divisibility test for 2. For 3, a whole number is divisible by 3 if and only if the sum of the digits of the whole number is divisible by 3. 38,679. If we add each of those numbers together, 3 plus 8 plus 6 plus 7 plus 9, we get 33. If we add 3 plus 3, we get 6. We see that 6 is divisible by 3, therefore the divisibility test for 3 is complete. In the divisibility test for 4, a number n is divisible by 4 if and only if 4 is a factor of the number formed by the final 2 digits of n. For example, 8,912. The last 2 digits are 12. 12 is divisible by 4. A number is divisible by 5 if and only if 5 is a factor of the ones digit. The final digit is 0 or 5. 105, the final digit is 5. 105 divided by 5 is 21. In divisibility test for 6, a number is divisible by 6 if the number is divisible by both 2 and 3. If 2 is a factor of the ones digit and the sum of the digits of the whole number is divisible by 3. 57,342. The last digit is 2. 5 plus 7 plus 3 plus 4 plus 2 is 21. 21 divided by 3 is 7. A whole number is divisible by 9 if and only if the sum of the digits of the whole number is divisible by 9. Shown here, 349,785. Just like before, we add all of these numbers together to get 36. We know 36 is divisible by 9, therefore, the divisibility test for 9 is complete. In the divisibility test for 10 and 12, a number is divisible by 10 if the number ends in 0. It's very simple. 3,210 shows the last digit is 0. Therefore, it's divisible by 10. A number is divisible by 12 if the number is divisible by both 3 and 4. If the sum of the digits of the whole number is divisible by 3, and if 4 is a factor of the number formed by the final two digits. In 324, we add those numbers together. 3 plus 2 plus 4 is 9. 9 divided by 3 is 3. 24 divided by 4 is 6. In divisibility test for 15 and 18, a number is divisible by 15 if it's divisible by 3 and 5. 315, if we add those together, 3 plus 1 plus 5, we get 9. 9 divided by 3 is 3. 15, which is the last two digits, divided by 5 is 3. In the divisibility test for 18, a number is divisible by 18 if it's divisible by 2 and 9. If the sum of the digits of the whole number is divisible by 9 and 2 is a factor of the ones digit. And we show an example here. In Objective 7, we show find a prime factorization of a number, perhaps using a factor tree. And here we show a factor tree for the number 36. In Objective 8, we explain why the square root test provides a way to know which prime numbers at most need to be tested when determining whether or not a number is prime. In Objective 9, we determine whether a number of a reasonable size is prime or composite. 29 is a prime number because it has exactly two factors, 1 and 9. A composite number is a whole number greater than 1 that has more than two factors. In Objective 10, we determine the number of factors of a number from its prime factorization form, shown below. In Objective 11, we find common factors of sets of numbers and find common multiples of sets of numbers. To find common factors, list out the factors and determine which one of them are the same. To find common multiples, list the sets of multiples and determine equivalent numbers. In Objective 12, we find the greatest common factor and the least common multiple of sets of numbers. To find the greatest common factor, list the common factors and determine the factor with the highest value. To find the least common multiple, find the lowest non-zero number between the sets of multiples. And finally, in Objective 13, we discuss common errors made in using the unique factorization theorem. The unique factorization theorem is a statement stating that a number greater than 1 is either prime number or has a unique prime factorization. An error that students can make when using the theorem is that they believe the prime factorization is just a possible factorization, so they might believe that another prime number could appear in the factorization. And here we're going to reduce a fraction to its lowest term. 15/35. In order to reduce this fraction, we would divide both the numerator and the denominator by 5. We see that 15 divided by 5 is 3, and 35 divided by 5 is 7. We know that neither one of these numbers are divisible any further, and that makes this the lowest term of the fraction 15/35. Thank you very much. We hope you've enjoyed our presentation.